Welcome, everyone. This is amazing being here. I've not been at JavaZone for a couple of years, and just this stage is crazy. I've never seen this, and we just found out. Look, the stage moves. Okay, so I'm Nikolai Palok. I'm a Java developer advocate for Oracle, and I'm here to tell you all about Java 23. And there's a few things to talk about in there, but we'll see that we might have to grab some features from elsewhere as well. I will focus on 23 though, but I will not cover all details, right? Many of these features, they're like good to understand on a surface level, and that's what I'm going to present to you. And then if you want to like really use them, there's often some details that you can dig in deeper, and there are always sources on these slides on where to go next. Specifically, go to the Java YouTube channel, and you'll find a lot there. Also, the slides are already online, and they work reasonably well on mobile if you want to follow along. If you have questions, and I know this, okay, I want to say ask questions anytime. I can barely see you, so. Well, we can still try. Be loud. As my colleague Alina just said, just yell loudly. If you're a loud person, I can hear you. OK, so there's lots to talk about. In Java 23, we have two final features, Markdown and JavaDoc, and primitive patterns, and two new preview features. And we're going to spend some time to look into those closely. And then after that, in case we have time left over, there's lots more to talk about in the space of Java 22. Maybe not everybody is on Java 22 already, so maybe you don't know all of these features by heart yet. And there's a bunch of ongoing preview features that we could look into, including the no longer ongoing preview for string templates. If you're curious about that, we can dig into that as well. But yeah, the first part I want to go over is Java 23 and those features and the new preview features, and then we'll see what else we can get to. OK, so writing JavaDoc. First of all, who has written code this week already? That's a lot of people. Keep your hands up, keep your hands up. Now, lower your hand if you have not written JavaDoc this week. And there goes like 2/3 of the hands. I was kind of expecting that. OK, every time, for every hands that lowered, Uncle Bob sent another tweet, right? So please do remember, comments are useful. Right, so writing JavaDoc overall, I think, is a pretty great experience, specifically for small sections of text, right, like maybe a paragraph or two. But once you get into more complex documentation, it really starts to get annoying, like the details. So for example, I can never remember where to put the paragraph tags. I usually don't put them anywhere, and then JavaDoc starts yelling at me, and then I have to look up where they go, and do we need the closing tag, and that kind of stuff. Code snippets are really cumbersome. Lists are verbose, and if you want to have tables, which I rarely do, but that's just outright terrible. And most of that I can lay at the feet of HTML. Right? It's not really JavaDoc's fault. JavaDoc adopted HTML back then, because back in the days that was like the language that you would use for markup. But nowadays we don't. Right? Like very few people really actively write HTML. We often write Markdown if you want to write text, or ASCII-Doc or other markup languages. And Markdown overall is more pleasant to write. Like you don't need to care about paragraphs specifically. Just leave a blank line and you get a new paragraph. You use backticks for inline code or for code blocks. Lists are super straightforward with the asterisks. Tables, still terrible, but less so though. Like again, I always have to look up how to make a Markdown table. By the way, if you need to do this, there are online generators for this. Just type Markdown table generator into the search engine of your choice, and you'll find a way where you can create a table like in Excel, which weirdly enough is the more usable, user-friendly model to do, and it'll spit it out in HTML or Markdown. And yeah, and if Markdown has some shortcomings, you can always just straight up embed HTML, which makes it super handy as a fallback. But maybe most importantly, because I would actually claim that ASCII-Doc is slightly superior to Markdown, but everybody knows Markdown, right? We use it on Stack Overflow, we use it in Slack, or on GitHub, of course, all of those places except Markdown, or some variant of Markdown, so it's very well known. So now we can use it in JavaDoc. If you want to have a Markdown comment in Java as a JavaDoc block, you would start it with 3 slashes, and then most of the common mark 0.3 spec works. So that's the newest common mark spec. And all those things that are designed in their work. For those of you who don't know, Markdown is not actually really well defined. It basically came up as an idea of what you could do, and then every platform adopts it in slightly different ways. And Common Mark tried to find a specification for that, so that parsers, for example, can unify on one syntax. One of the rare exceptions where it doesn't quite follow along what you would expect from Markdown is when you want to link to another element, program element, like another package or a method or a class. You would use what's called the reference link syntax, which is 2 brackets next to one another. And then JavaDoc tags still work. I brought an example from the JEP. You don't need to read the exact details. That's not what this is about. But what you can see on your left-hand side is the old style JavaDoc. And on the right-hand side, you can see the Markdown version. And what you can see, for example, is how a bunch of things just disappear. The paragraph tags, the list tags, and then there's not even a code example, like a code block here that would also become easier. But importantly, at the bottom, return, at C, at impulse spec, those JavaDoc tags still just work. They expect then Markdown text within them instead of HTML. And that way you can just simplify your JavaDoc. So if those people who lowered their hand earlier, maybe it was because writing JavaDoc is annoying in HTML, maybe now you write a comment after all. Why the 3 slashes? Wouldn't it be nice to do something like this? We already have the / ** syntax. If you could just put the language there, like with the fenced code blocks, just write Markdown or maybe in the future ASCII doc or whatever, wouldn't that be cool? And yet definitely, that would really be nice, but it wouldn't actually work in practice. One thing that I didn't know is the case, actually, is that the leading asterisk in JavaDoc is entirely optional. You don't have to put it there, so the parser does not require it. And then in this situation, the parser would be confused. Is that asterisk in front of item, or why there are 2 item number 1s? Copy paste. Is that intentional? Is that part of the Markdown syntax? Is that part of the JavaDoc syntax? So that would just plain up not work. I have another example here, which is really well visualized on my slides, which is this is gray, right? Because it's a comment block, a Java comment block, and my code highlighter puts it at gray. But here it stops being gray after a while because there's an asterisk / embedded in my comment, because my JavaDoc comment contains a code example, and my code example contains a comment. And this would not be possible because, of course, the asterisk / closes the JavaDoc comment. And you can see here, right, by how my code highlighter gets confused and colors the rest in white. So yeah. That's why that's not going to work. 3 / have no such issues, and also they do not require any new Java syntax because 2 / already escape the regular parsing. And although not very important, other languages also have kind of settled on these 3 slashes for some of their doc comments, so it has some level of familiarity, but as I said, it's really not important. If you want to go deeper into this, JEP 467, JDK Enhancement Proposal 467 has all the details, and my colleague Anna summarized the most important of them in this video, and then you can check that out there. Okay, let's do Gen ZGC by default. Also be a little bit of a quick one. The important part is the by default, that's new. But let's talk about generational ZGC in general, or let's start first with ZGC. Every garbage collector has different trade-offs, right? If there would be one perfect garbage collector that clears up everything immediately without overhead, that would be nice, but no such thing exists. And ZGC squarely goes into ultra-low pause times. That's what it cares about. And that comes at the cost that it can have higher CPU and memory overhead than other GCs. So for example, if you run a nightly batch job, you just want like maximum performance, you would use parallel GC because you don't care about pause times, right? There can be 10 seconds pauses, who cares? If you have something where the user is supposed to interact with constantly, then having a 10-second pause is probably not a good idea, or even just a half-second pause. And ZGC says, okay, I'm going to promise you, regardless of how gigantic the heap is, that I can clear this and sub-millisecond pauses, but that comes with some overhead. And in JDK 21, GGC became generational. And the generational hypothesis is that most objects die young. You can see that in methods, right? Within a method, you create a bunch of objects. Those actually often don't even end up on the heap, but be that as it may. Even within classes, instances are created and quickly lost again and get garbage collected. Those that survive this initial burst often live very, very long. And it makes sense for garbage collectors to track this individually. And GGC didn't do that. And it started doing it in 21. And that was very promising. Netflix published a great blog post about this. I have 2 totally out of context graphs for you. I just want to highlight a few things. And then if you're interested in this, you need to look at this closer. Can I see a cursor? Okay, I'm not sure whether you can see the cursor. Here on the right-hand side, the gray block is their memory utilization before the update, and the blue line is after the update. You can see how it dips a bit. So they have like, I don't know, whatever it is, like 10% maybe less memory utilization after switching from G1. More importantly, these are their average pause times. The graph is not incomplete. The block on the right does contain pause times. They're so small they don't show up on the graph. So that's good, is what I learned from the blog post. So if this looks like something you might want in your own app and you can pay with the somewhat higher CPU utilization that this will likely bring compared to G1, then you should give this a try. Just generally speaking, if you do care about performance, if you do have performance benchmarks set up, just give it a try. It's super easy, and then you'll see whether it works or not. Since JDK 23, you no longer need to unlock the generational mode specifically. So if you are on 21, you can try ZGC, even generational mode, but you would have to look through an older JEP to see what the extra flag for that is. And this is important to understand. The generational mode is now the default for ZGC, but the default garbage collector is still G1 because it sits in between ZGC and parallel GC. It sits in the trade-off in both directions part of that graph. Okay, so JEP 439 introduced generation ZGC. It will explain to you how to use this on 21, and it also applies to 22. And then on 23, the generational mode became default. This is the blog post by Netflix, bending pause times to your will with generation ZGC. I think they stole a little bit of the avatar fame there with the bending. It's also part of their there's a photo of that in the blog post as well. And then again, 2 videos that our team made that you can check out and learn more about the details if you're interested. Okay. By the way, if you do have questions, as I said, you can try to ask, but I don't see any raised hands, so I'll just keep going. Okay, let's talk about primitive patterns. Or before we get there, let's talk about patterns in general. So in instance of, as well as in Switch, over the last couple of years, we got a lot of new things we can do. We can match against specific reference types. We can deconstruct records with these construction patterns. We can nest patterns where you deconstruct something and then put another pattern in the center. We can use the underscore to ignore patterns. To ignore patterns or variables in a pattern. And in Switch, we can use all of that and then also have guarded patterns there. So that's a bunch of features that Java accumulated over the last couple of years. And those are not random, of course. I would claim that these plus seal types are the record pattern basics. That's what you need to do like actual pattern matching in the language. If you just, remove 1 or 2 features from that list earlier, it would feel very incomplete. So now we basically got the basics and things are working. And now there's 2 directions this can go in. New features can be built on top and make this higher and give us like just more things we can do. But we also need to build this out to the side. There are certain parts of the language that basically are not served by patterns, and it's a little bit of an imbalance. And as an example for that, I have an instance of operation for you. So in the past, if you wrote x instance of y, what it meant was, is the variable x of the type y? But that's not what it means anymore. Now y can be a pattern. And so now you're not asking, is x an instance of that pattern? It's more like, is x an instance that matches the pattern, right? So that's like the little slight mental switch you have to, or like change of angle that you have to do to properly understand this new operation. It's no longer a question, is this literally an instance of that type, but does it match that pattern? And for primitives, the old semantics never made sense. You would never have a variable where you could say, are you an instance of an int or of lowercase b byte? And the reason why that wouldn't make sense is because, well, the variable must be declared as some kind of type, and either it is declared as an int, then yes, it's trivially an instance of int, or it's not declared as an int, then why are you asking? Like, obviously it's not. There's no way to generalize over that, right? And so that question didn't make sense, and so it wasn't allowed. But now if you're asking, does the variable match this int pattern, then that could make sense. Specifically for bounce checks, for example, let's say I have an int number 0. Now, can number be an instance of byte? In the literal original sense, can int be an instance of byte? No, it's an int. It's a different type, right? So that doesn't work. But can it be a value of a byte? So can its value be a byte? Can the number 0 be a byte? Sure, it's within the bounds. So yeah, that definitely works. And that's something that as a preview feature in JDK 23 now works. You can write and x is 0, and then if x is an instance of byte b, and that check will be true if x is in the range of a byte. So if in the past you would have to go from int to byte or from long to int, which is probably more likely, then you would have to do a bounce check manually. And then now you don't need to do this anymore. Now you can just ask, is an instance of that, and then you do your thing, and otherwise you do the else branch. You can do more checks, though. So here's a special number. I didn't know that special number by heart. I had to look it up. 16,777,216. Anybody know why this number is special? Like, this would be really impressive, by the way. It's like a 10 out of 10 question. Sorry? He says it's 2 to the power of 24. That is entirely possible, I'm just not sure whether, I'm not sure whether it's true. Let me see. Can we do the Mac thing and ask? Oh, wow. That's great. Actually, that could be a hint. That's good. I'm very impressed. So, but why is that important? It's the smallest positive int that a float can represent. A float has a larger range than an int. So you would think every int can be a float, but then also if you think a second longer, that doesn't make sense because it's the same number of bits. So how would that work? And the reason is that float is not infinitely precise, right? So we can also do precision checks. Is this number an instance of float? Yeah, it is, because I can represent it as a float perfectly. If you would increase the number by 1, if you go to 16,217,000, then this would not be an instance of float. You can cast it to a float, but you would lose precision. And this would be so much harder to implement manually than a bounce check for byte would be, right? So you can see how this can have some value. Another big one is tri-state booleans. If you get a capital B boolean from somewhere and you're wondering, is it true, is it false? It could also be null. Now you can do this to differentiate the 3 cases, even though clearly one of them is an evil case. Funnily enough, this is bugged in 23, and by the time this was reported, it was not considered important enough because, once ramp down phases start, once JDK gets closer to a release, only critical bugs can be fixed. This is not critical. It's fixed now. It will be shipped in 23.01, and the 24 EA build already contains it. So it's a little bit sad, but there you go. If you want to learn more about this, JEP 455 has got you covered. And then I made a video about that, focusing a lot on which patterns we have and why this is important. Because as you can see, the content itself is not enough to fill a 5-minute video, but there's a lot around that that's interesting to learn how this connects to other such patterns. Okay, we're already nearing the end of what is new in 23. The last new preview feature I have for you is module imports. So I want to, by a show of hands, which one do you prefer? So the first one is just regular specific imports for everything that you need. The second one is a star import, where you just say, just give me what's in that package, or give me all the types. So who prefers option A? That's a lot of people. I want to guess like at least 60%. Who prefers option B? That's very few people. Everybody in between is like, I don't write code anymore. I'm a software architect now. Okay, so star imports do have some upsides. They're more succinct, which often doesn't matter so much to us because, the IDE generates them. But if you do need to manage them manually, that's obviously much simpler. The downside is it's less clear, has a chance of conflicts. You can more easily import two types with the same simple name from 2 different packages. And also gives you kind of like an arbitrary slice of an API. If you go into something like the swing packages, for example, you just import one of them, you get like an incomplete slice of this API, which is kind of weird. Enter module imports, which are a preview feature in JDK 23. Now you can write import module and then the name of a module. So if in 2017 you actually learned about modules and you felt betrayed because for 7 years you couldn't put this knowledge to practice, now there's something connected to modules that you might use in your daily life. Importantly, your code doesn't need to be in a module though, if you don't want to. And now we import the public API of that module. What exactly the public API is, it's not easy to describe in a single sentence. So I put it on the bullet points here. First and foremost, those are all the public top-level types in the packages exported by that module. That part is clear, and if you know modules, that's kind of obvious. The other 2 ones might not be that obvious. If you have qualified exports to your module, then you can read all of those types too. And if they require transitive something, then you can read that as well. That might seem arbitrary and weird, but if you've dealt with modules, then that makes sense because it means every public type you get a dependency on through that module, you will now be able to use directly. So if you do like star imports, I would claim this is an improvement. It's even more succinct than star imports, and it's trivial, even easier to manage them manually. You just go import module Java XML, and you get the whole Java XML API right there. Of course, it's still less detailed, and it still runs the risk of conflicts. Brief discussion of those. In this specific situation, I'm importing Java Base, Java Desktop, and Java SQL, and I'm doing 2 things. I'm creating a date, and I'm creating a list. And now both of those are ambiguous because there are dates in SQL and in Java Base, and there is a list in Java Base and Java SQL. And just like with star imports, you would have to fix those manually. So just in case you run into that, this would be the solution. You can just add specifically, this date type. But also don't use this date type, right? It's you try to use the types added in Java 8. Although recently I had to use them because I used an old dependency and I felt dirty writing a new date. It was very weird. I haven't done that in, I don't know, almost 10 years. when you are already using star imports, when you only kind of like them, then I think that module imports are just a clear upgrade. Everything that star imports do, they do better. But more importantly, and this is the real reason why they were introduced, was if you're writing short pieces of code, a script, an experiment, a demo, something succinct, and you want to show somebody how to do some XML stuff in Java, you can just write import Java SQL, Java XML at the top, import module Java XML, and there you go. And the cool thing is, and maybe we're going to get to that later, if you have an implicitly declared class, it implicitly imports the module Java base. So I have a void main here. Let's first ignore the comment and go through there. What the code specifically doesn't matter. It's a main method that does something with a stream. I use big decimal, I use local date, random generator, what else? ToList, streams, all of that. I need to import none of that because this is the complete source file. There's nothing extra around it. There's no class wrap around it, nothing. This is what's called an implicitly declared class. We're probably going to get to that later. And for those classes, Java just says, look, since you are trying to be succinct and trying to just write a little bit, let me make life easier for you and just import the whole Java base API. So everything that's in the Java base module, you can use for free here without any explicit imports. I think that's pretty neat. So if you do these kinds of experiments, and I started to do them daily, like whenever I code, but also whenever I write a blog post or write a script, there's always something like, well, how does it work again? And I just have a text editor somewhere with a main.java in. I just write a little main method, run it on the terminal, and it's super easy to experiment with. Want to learn more about this? There's a JEP about it, and we also made a video about that. You can see how this goes, right? Somebody makes a JEP, we make a video, I make slides, I talk to you, and then now you can dig deeper if you want to. Okay, that will be my session. Thank you very much for coming. Now that's JDK 23. That's what's new in JDK 23. As I said, I have more features to talk to you about. But before we do that, I kind of want to talk to you about deprecations. So that's important. That's an ongoing thing that is happening and that you should be aware of. It's not quite as interesting and amazing as using new features, but that's life. First of all, if you are on JDK 11, for example, or 8, actually, you know what? Maybe this is a great time to ask. So I want to ask what Java version you're on, and I want to make the results as favorable as much in my favor as possible. And I was interested in people using new Java features and new Java languages. So I'm going to ask, what is the newest JDK version you are running in production? You or your team, not your entire company, right? Like what you are responsible for. What is the newest JDK version that you're running in production? So let's start at the low end. Who's using something as the newest version before 8? Please, for the love of... Okay, good. 8 then. 8? Wow, that's like, I don't know, I saw like 3 shameful hands. I mean, they went up like this, so that's why I'm assuming that they were shameful. But that's amazing. It's really few people. I mean, of course, as I said, like I biased the question in my favor, but still, who's on 11 as the newest? That's also very few people. 17. That's more like 20-30%. 21? Holy moly, this is amazing. Like this is, I've never seen 21 trounced 11 that hard. Oh, sorry, I forgot 17 and 11 that hard. Anybody on 22? No. At least I didn't see anybody. That's sad. Should we do the inverse? Should we ask what's your oldest Java version is that you're running in production? Let's try this. I never tried this. Okay, so what's your oldest JDK version that you're running in production? For whom of that is that something lower than 8? That's a few more 8. Couple more 11. Okay, now I think we're going to like the 10-20% range. 17 then the oldest. That's probably going to be, okay, and 21 then? Oh, that's interesting. So that means that a lot of people are basically just running like a short range of versions, right? So it's not like you're responsible for Java 6, 8, 11, and 21. It feels like about the same people raise their hands for the highest version is 17 and 21 and the lowest version is. Okay, thank you very much for giving me that insight. It's always interesting. I mean, the group is clearly self-selected. You're more likely to be interested in new Java versions than the average Java developer just because you're here, just because you came to this talk. But I still think it's really important because there's kind of like this narrative that, oh yeah, everybody is still on 8. And I don't know, maybe somewhere, but not where I ask the people. That's where they're often on new versions. Okay, so that means though that a couple of you are still on 11. And please don't use any of these technologies. They're already gone. So now is not a good time to use them anymore. Although Nashorn, I think, exists as a separate project. It's just gone out of the JDK, but I'm not sure about that. But there's a lot of ongoing deprecations too. I'm going to leave that list up there for a second. We're going to go through some of them in a couple minutes. I just want to give you a general overview of how this works. Something is not deprecated because, I don't know, Dr. Deprecator, Stuart Marks, is sick of maintaining and he's just like, I don't want to do this anymore, just let's kill it. That's not how it goes, right? Java is backwards compatible and wants to be backwards compatible. Things are removed for very specific reasons. One of them could just be, it's like the way to use it, it's kind of dangerous, or it's a serious performance issue if you use it. Like there's pitfalls in there that make it more likely that it's accidentally misused than used correctly. That, for example, applies to Security Manager, which is really hard to use really correctly. Like it's really easy to use the Security Manager and get the impression that you're doing it right and everything is safe now without it being the case. Another thing is that it's just ongoing work that isn't worth the effort anymore. So there's a Windows 32-bit port here, and Microsoft said, I think for good reason, a couple years ago, yeah, we're not going to do that anymore. There is basically no Windows 32 bits out there anymore, so we're going to stop supporting that. Also, this also applies to a Security Manager. This also applies to finalization. There's a lot of things that have a constant maintenance effort, and if it's rarely used or just outdated technology, keeping maintaining it and making sure that every new feature works with it is just a constant drag on OpenJDK's development, and that's the reason why these things, or one of the reasons why these things are removed. I want to go through a few things on that list to tell you what you're supposed to do about this. Let's start with unsafe. The methods for memory access are deprecated for removal, so not everything, but those are, and they have been superseded by other APIs. And they will be phased out over the next coming releases. So 23 introduced the deprecation and a compile time warning. I mean, the deprecation for removal and the compile time warning. You get a runtime version, runtime warning, probably starting in 25. And then soon after, you will get an exception on invocation. And then they will eventually be removed. And at that point, you cannot even compile code against them anymore. Now, it's very unlikely that you are using unsafe directly. But your dependencies may very well do that. And there's a new command line flag that you can use to foreshadow what's going to happen. So I recommend to everybody to go home and run your test suite or performance benchmark, something that integration tests, something that runs the whole system, not just unit tests. They often don't touch on, or not often, but they may not touch on these critical code paths. And just go to deny. Just like set this flag, sunmisc, unsafe memory access to deny, and you will just see, the JVM will just crash out and be like, uncaught exception, unsupported operation exception, I think it's what it is. And then you can figure out who is throwing that exception, which of your dependencies is there. You can report that if they don't know it already. And then also, importantly, you can help fix that. I just had an interesting conversation with a great open source maintainer down here who, like the open source software we use is created often in the free time by people working on it. And so if you can help them fix this issue, or maybe even throw some money their way, your company could specifically, that would probably be great help. So yeah. Do that to figure out whether you are impacted by this, and if you are, then you need to find out whether they are aware and potentially help them fix it. Let's talk about agents. So we're done with unsafe now. We're talking about a different thing that's getting deprecated. It's agents, or not all of agents. Hear me out. What is an agent? An agent is a piece of program that can transform your bytecode. It uses a specific API, the Java Lang instrument or JVMTI. And there are two ways to use agents. One of them is to launch them with the JVM by some extra command line flags. And the other is to attach them to a running JVM. That's what's called dynamic agents. And now we're going to talk about only the dynamic agents. Everything that they can do remains intact. Everything that you might have, again, likely your dependencies are using a dynamic agent for, all of that still works. Nothing changes there. But in the future, what you will not be able to do to attach an agent by default. Since the agent does manipulate your bytecode of your running application, it can make deep changes to what is going on in your app, right? So this can totally turn on its head everything that your application is doing, from performance to security to just business domain logic. It's just like everything could go out the window, hypothetically. And what the idea here is that this should not be able to happen without you agreeing to it. So you're supposed to agree at launch time that, yes, it will be possible to attach a dynamic agent later. That's what you need this flag for. So if you want to use dynamic agents, all you need to do is observe that flag, or if you want to figure it out, you can put a little, So there's a plus here. That's what you will need to do in the future to enable dynamic agents. There is a minus here in that you can already use that today and turn dynamic agents off. And then you can see whether anything changes. Again, trying to find out whether this change will impact you this way. That's dynamic agents. Let's talk about finalization quickly. That's the finalized methods that you have an object that you can implement. And there's a lot of, within the Java language specification, as well within in garbage collectors, there's a lot of extra machinery for them. That was the old way to clear up resources. The try with resources block is the better way to do that now, where it works. I'm going to come to that in a second. Finalization is like, it cuts across the board. Like garbage collection has to keep track of this. For example, the DGC team estimated that they can get rid of about 1.5% of the memory overhead if they do not keep to track this anymore. If they do not need to track this anymore, which is not substantial, but it's decent, right? Like it's a nice saving to get. And overall, it's a superseded construct that makes things complicated. And it's also it's making things complicated for us if you use them, but also for maintaining the JDK. So for now, you can disable it if you want to, and it will be disabled in the future, and at some point it will be entirely removed. So what you should do is you should look where you have finalized methods in your code, where you implement those. Do try with resources instead, and if that doesn't cut it, there is a cleaner API which has some of the downsides of finalization, but not all, and is more general. So try with resources clearly only works if you have everything is scoped within a block. If that doesn't apply, this API can help you out. Same is true for your dependencies, so you have to check there as well. Or again, you can already run with finalization disabled. So you can see the pattern here, right? Something is going to be disabled in the future, and we now get the command line flags we need to simulate that future and to see whether we're impacted, so we can change our code, change our dependencies, make sure we're up to date, so if the dependency updates in a few months, we can get that. Okay, I think this should be the last one. Security Manager as a system of checks and permissions that is applied to your code. It's intended to safeguard security-relevant code sections. This code is security-relevant. Not everybody can call it. Only certain users can. The Security Manager as a class embodies this. And this is not used very widely. May I ask who has an active Security Manager running in the application? So this rounds down to 0, as I again didn't see any hands. This is, what the observation of OpenJDK is as well. It's already disallowed by default. You can still allow it, and in the future will be entirely removed. If you already are on 23, for example, on 21, I think even, you can just run your app in the default settings, and if everything works, that means you're not impacted, and otherwise you need to investigate and move away from the Security Manager. Oh, there's one more thing. Right, I forgot about that. There's one more deprecation. This is just outright deprecated for removal. The primitive wrapper constructors will be removed because Valhalla is this will not work well with Valhalla. The Java language specification says if you call a constructor with new, you will get a new instance that is different from all the other instances. And Valhalla comes along and says, hey, we're creating types that don't have an identity and that are indistinguishable from other types with the same values. So this is at conflict, and this is why this needs to be removed. They're already deprecated for removal. You can just go integer value off or double value off. Those are the things of choice. Okay, just describe that. This is the replacement, so it's already straightforward. If you want to learn more about this, if any of these technologies rang a bell, like, are we using this? I think I've seen this before. Do read up on those JEPs. With the features, with the new features I described, just go in, try and error like that. That's probably going to get you very far. But with these removals, I really urge you, if those apply to you, do read the JEPs carefully to make sure that you understand the reasoning why, you understand the way that this is going to pan out in the future, and what you can and should do to make sure that your code will work on that. But if you don't want to, there's a video there. Okay, now I got, wow, 25 minutes left, is that right? Got an hour, right? 25 minutes left. Okay, so yeah, I got heckled by my colleague. So I think I got like 25 minutes left, and we have a bunch of features to talk about. Unnamed patterns, foreign function memory API, and launching programs, simplified main, that kind of stuff. And then there's a bunch of preview features here. Now, I don't think we can get through all of them, but we can get to many apparently. And I just want to go by whatever you prefer. There's no specific order to this. It doesn't matter. We can just pick whatever you want. So the first thing that I can understand here being yelled the loudest, we can pick that. So any preference by anybody? FFM. Oh, people want to know FFM. Went straight to my weakest point. Thank you very much. Because this has to do with C. And I still have some slides I will show you, but let me get my excuse out first. I learned Java programming in high school and then university, never touched C. And being a Linux fanboy, I was like, maybe I should learn C and C++ so I can contribute. So I cleared out a week and I was like, okay, this weekend I'm going to start. I'm going to do some tutorials. I'm going to get into this. After 4 hours, I basically did the table flip. And I was like, no, I'm going to learn a program language. I'm going to learn one that makes my life easier, not harder. I'm not going to do this. So I got no clue about C really. So that might show in the slides. Do forgive me. So foreign FFM is foreign function and memory API. We're going to start with foreign memory. Foreign memory means memory that is not guarded by the garbage collector, right? It's still probably in RAM, but it could also be elsewhere, but that doesn't matter. The point is the garbage collector is not in charge of it. It will not clear things up. And Java always allowed that, right? The byte buffer, you could do that. That's basically what the byte buffer is. It's just like, here's 2 gigabytes of unnamed memory. It will get cleared all of it once the byte buffer is no longer referenced, but within those 2 gigabytes, you can use bytes however you want. But it's just 2 gigabytes, which nowadays is not a lot. It's inefficient to use, and that's why people used unsafe. As I said earlier, right, the unsafe memory methods that are being deprecated and removed, those are the ones that people used instead, but those are, say it with me, unsafe. So in the sense that it's very easy to just crash your JVM with them, like a real crash, right? Like, like touching memory that you're not supposed to and stuff. But also it's not supported. These APIs can change and that could cause issues. And that's why you're stuck between using byte buffer, which is and unsafe, which you really shouldn't. So new option was clearly needed. And Project Panama introduced the safe and performant API. It allowed you much more control over the memory. So byte buffer was just like a single class. And here you get arena, memory segment, and segment allocator as the core classes. And then if you want to access and manipulate the memory, you get memory layout and var handle. This seems like, before I just had byte buffer, now I have like at least 5 types. Why is it so much more complicated? And I like to compare that to the old date and calendar API. You really only had the types calendar and date. And then JavaDoc and later JDK8's date and time API comes along and has like a gazillion types. And the question is, why are you making this so complicated? And the answer to that is, nobody's making it complicated. It is complicated, but the old API tried to hide all of that. It tried to put all the complexity under the rug and hide it there, and that often doesn't work well. And so more types does not necessarily mean that the API is more complex. It just means that the complexity that is in the domain is now accessible to you, and you can manage it, when in the past you would have to rely on whatever abstraction the API chose to really hit the nail on the head and do exactly what you want. And if it didn't, you had a really hard time with it. Okay, so this is how you would use it. You would create an arena, and within that arena, you can manage all kinds of off-heap memory. And this immediately has a lifetime. It's a try with resources block. So when the end of the curly brace there, the memory is deallocated and removed, which is not something that byte buffer, for example, does reliably. So that's already one advantage. And then we're now going to see a few slides of code, and it's not important what each detail in that slides do, but the structure is I think, important. That's what I want to get across. You would create one of these arenas, and then you would take something that you have on your heap, and you will shuffle it off heap. And then, in all likelihood, the reason for that is that you want to run some native code on that, right? Something that's not JDK code, that doesn't run in the JVM, and it does its thing. And then, if you're done, you probably want to get data back into your system to then keep your Java program coding running. So this is what we're going to do: push stuff off heap, run the native code, and then get it back on. So let's start with the first part, where we allocate off heap memory and then store some pointers in there. So I have an array of Java strings here. And then I need to do a few things. I need to go through that off-heap arena and say I want to allocate an array. There's an address here. There's a length here. And then I go through this loop. And in this loop, I wish this could work, right? Yeah. And here you have to go like, okay, I need to allocate a UTF-8 string. And then I need to set a specific index. Again, the details are not terribly important. But what you can see here, you can see how this is much more detailed than Java memory management, because you have to be specific about how many bytes is this, how long is it, where is it, all of that stuff. And the API tries to help you with that by giving you the tools you need, but also making very that it can match different use cases easily. Okay, so now we shuffle that stuff off heap. Somewhere some code was running probably on it, and now we want to get it back. And this code is basically the inverse of what we did before. Now we're getting stuff at a specific index, and we're interpreting it as a UTF-8 string. And so we're getting it back, we're putting it back into our array. So this was the first and the third step. Now let's go to the second step in between. They don't have to be used together, right? You can use off-heap memory for other reasons than foreign functions, and you can use foreign functions without off-heap memory, for example, to make syscalls. Just, this is the way you will often use them together. Let's talk about the Java native interface. That isn't ideal either. It involves several tedious processes and artifacts that are not easy to get right. It can only interoperate with languages that somewhat closely align with what JVM works with. And if type system differences exist, it doesn't really do anything to reconcile them. And the foreign function API, again, tries to overcome those shortcomings. So Project Panama introduced first an API, new API, how to call into foreign functions that uses method handles. And that writing that method handle code is two things. It's kind of like, I won't say complicated necessarily, but it's repetitive and you have to get it right. But also, it's very predictable. If you have a header file or a function file, you can generate this low-level adaptation, and that's what JExtract does. So the idea here is that you would take a C file, you run JExtract, and then you get a very low-level Java API on top, and then you write a proper Java API on top of that. And if ever the C file changes, you regenerate the low-level part, and then you will see all the compile errors in your layer on top of that, and you will fix those. And that way, hopefully, it will be easier for projects that do adopt C code for Java or C++ code for Java. That will hopefully become easier for them to keep up to date. That has been a recurring challenge for projects that do that it's a lot of manual work to get something work in JNI. And if the C library updates and has severe changes in its API, then a lot of that manual work has to be redone. And the hope is that JExtract can extract that so much better, and then you do not have to do that manual work, and you can only work on adapting your Java API for the new API. Okay, so this is what that would look like. You get a native linker and do a symbol lookup, and then you ask it, give me radix sort, for example. So if the standard lib on my operating system has a radix sort, now the method handle of the name radix sort references that native function. And then we do the arena, we shuffle everything off heap, and now we say radix sort invoke, and we give it a bunch of things, right? We give it the pointers and the memory layout and how long it's gonna run, like how long that array is. We give it all of that. It does its thing. Presumably, it does that in that array. So the array later is still the same array, but now it's sorted. And then comes the part where we copy stuff back. Importantly, this is now final. This has been in first incubation and then preview since, I don't know, I think like 13 or 14 for a really long time. First, I think for in function and then for in memory, or the other way around. Then they were married together. They became a preview feature, and then the preview API. And then 21, they were almost ready to be finalized, but not quite. And so it took another round of reviews, for preview and feedback. And now in 22, it's final. So if you're looking for this, if you're on 21, this could be a reason for you to update to 22. There's more to do, though. So for one, I just said C++ earlier. I don't think it actually works with C++. And the reason for that is kind of crazy to me, because apparently C++ is not sufficiently standardized that it's easy to do that, because different compilers can create different artifacts. Again, not my wheelhouse, so if that is wrong, please forgive me. But that's my understanding why C++ is not actually supported yet. So there's a lot of things that still needs to be, or should be, or could be worked on in this space. Again, here's the JEP. I don't have one of my videos because, as I said, not my strong suit, but Maurizio Shimadamoro, who developed much of this and was the lead on Project Panama, he has a great talk out from, I think, last year. I think from last year, yeah, that you can go look, and he goes into much more detail and explains this probably much better than I do. And there's also the mailing list. If you do use any of this and you do have any experiences or feedback, please take it to a mailing list. This is definitely a niche subject, so while something like string templates or primitive patterns might get more feedback, something like this might not. So if you do have feedback, please share it on the mailing list. Okay. Anything else that we want to talk about?
Unnamed patterns.
Unnamed patterns. There we go. Okay, let's go with unnamed patterns. Oh, there's my little demo app showing up after all. Okay, so I have a very simple demo app. I have to so before we go into unnamed patterns, I have to do a little bit of a build-up. I have to present to you a case for why they're useful, because that's more important than how to use them. The how to use them part is so easy. I can do it in 10 seconds. We only sell a glass of beer, probably over a shot of vodka because, 10 seconds only. So it's super simple to use them, but it's important to understand why you want to use them, which specific circumstance they come in super, super handy. So, okay, let's talk about this. Let's say I have a little GitHub scraper, and what it does, it goes to GitHub and it downloads just the HTML pages and does a few things there. And the way I model this is I create a page class, or interface, I should say, and now I have 4 subtypes: GitHub issue page, pull request page, external page, and error page. And then I do something with those pages. I could do all kinds of stuff, display them in interactive graphs, graph properties, categorize them, mood analysis. I want to invoice for all of my cool features here. Lots of different systems operating on these 4 core types. How do you implement those? You could put all of those methods on the same page, right? So then you have a type that has, here's the payment system, and here's a 2D canvas. Here's the mood analyzer, and here's a graph property analyzer. That would be kind of crazy to have a design where this type knows your entire system, basically. So that's not good. You can use the visitor pattern, which is the correct object-oriented solution, but still, I really don't like it, because I've worked in a code base which used it a lot for good reasons and correct reasons. Still, it's not fun to use. Now you can use pattern matching. So that's what we're going to do. For that, we need a bunch of ingredients that I already mentioned earlier: switch expressions, type patterns, seal types, and now at the very bottom, unnamed patterns. And this is what this is about. I want to tell you why unnamed patterns are important in this context. The way we do that with pattern matching is by making the page type sealed. So you write public sealed interface. We're going to see it on the next slide. And then you implement all your features, not as methods on that page type, but as methods elsewhere. The payment subsystem now has a create invoice method that gets a page, for example. And the 2D canvas now has a draw method that takes a page as input. And then you switch over the page instance to find out what type we're in. And the last part gets to the story. We want to avoid a default branch. I'm going to tell you why in a second. Okay, so with sealed types, this is a pattern matching force march through pattern matching, right? If you never heard about this, this is a lot. Like if you can't follow every detail, that's perfectly fine. Right, so this is why you use a sealed type to limit inheritance. You write public sealed interface page. You can also have sealed classes, but we're going to focus on interfaces. And then you write which types are permitted to implement or extend that interface. And no other type can. If I create, Friday afternoon, the product owner comes in and says, oh no, we found out GitHub also has commit pages. Please implement GitHub commit page. I can write public class GitHub commit page implements page. And then I can point to compile error and say, oh, no, it doesn't work. See, because it's not permitted, then I can go on my weekend. So that's what happens. If you add an additional implementation, you will get a compile error. And that's great, because a situation like this, I can switch over all 4 types, and now we kind of know those are all the 4 types that are possible, right? A page must be of one of those 4 types. But the interesting thing is, it's not just us knowing that. The compiler knows that too. If you do an if-else-if chain over if it's instance of that, if it's instance of that, and you miss a case, well, that's your bad. You probably have to have an else default branch anyway, like an else branch in the end that maybe throws an exception. But a pattern switch needs to be exhaustive. The switch insists of you listing all types, and if you do, it's happy. So if you switch over a sealed type and have a case per subtype, and you do avoid a default branch, you will get a compile error, because you get a compile error if you add a new type. So let's see how that works. We added a new type now. We added GitHub commit page. And we extended the sealed interface. We said it now also permits GitHub commit page. And at that moment, the compiler knows that this is no longer complete. It throws you to this switch and every other such switch and tells you there's a case missing here. And that is crucial. That's what the whole indirection of the visitor pattern achieved. That you can have operations outside of a type, but if you add a new type to that hierarchy, all your operations will get a compile error. That's why the whole effort of the visitor pattern exists, to give you this, to afford you this compile time safety. And switch over sealed type does the same, but much simpler. So I added this new type, and now I get a compile error. And that is good. Okay, so and now we start going into unnamed patterns, okay? So this is the part where we are. We want to have an exhaustive switch over all types. But we don't want to have a default branch. Right? Because if we do have a default branch like this is also exhaustive. It covers all types. Whatever other types exist except those 2, they will go to the default branch and everything is fine. But the problem is, now the GitHub commit page also goes into the default branch. And presumably, that's not what I wanted. right? So that's the problem here. The problem is that for now, this might look good, but it's not maintainable in the sense that in the future, when I add more types, I do not get compile errors, and I silently fall into this branch, and then, hopefully I have tests that catch this, otherwise this would be a runtime problem. So I want to avoid the default branch. And this is how you do it in 21, which is, it's not great. You just have to duplicate the branch. You cannot combine these branches, by the way. You cannot say case error page R or ERR, comma, external page X. And the reason why you cannot combine these, because then the compiler doesn't know which of those types matched, and then you can use neither of the variables on the right-hand side, because can you use X? No, it could be the other type. Can you use ERR? No, it could be the other type. So you cannot combine them. Finally, here we are. With unnamed patterns, you can combine them. With unnamed patterns just means I don't care about this match. Yes, I want to know whether it matched error page, but I do not care about the variable. I don't need a variable here. And then you cannot reference the variable. And then you can combine these two branches, because now you're saying whether it matched error page or external page, that fact is important to me, but I'm never going to use it at either of those types. And that's why you can combine them. And while you can use unnamed patterns in other places, everywhere where you can use a pattern, you can say, I don't need this here, just put an underscore. Even for unused variables, if you write a lambda, right, like maybe you want to write, so for example, compute if absent on concurrent map does that. It's even on the map contract now, right? Where you have to provide a function, and that function gets a parameter, gets an argument that you often don't need. Or maybe you're implementing a by function and you only need the first one, you don't need the second one. How do the second variable was always unused, maybe you call it unused, maybe you give it a single letter variable name to punish it for being unused. Now you can just use underscore in all of those places where you don't need something. And that's nice and a nice quality of life improvement everywhere. But here it really becomes important. That's why I honed in on this specific use case, because this really makes these switches over sealed types much more ergonomic while still being fully maintainable. Okay. That's that JEP, and that's that JDK. That's a video on that as well. Okay. Do you want to hear why string templates are gone? Anybody interested in that? Yes, few people. Okay. So composing strings in Java isn't always fun. What I want to do here is and if you cringe about, please don't take a photo of that slide yet. What I'm doing here is not good. I'm combining strings to create an SQL statement. And that is not only cumbersome in these different ways, it also comes with a free SQL injection. Now you can take a photo. And that's not what you're supposed to do, right? Other languages allow this. You can just go with, I had to line break this, right? Otherwise because of the slides, otherwise would fit in one line. Select star from person where P, and now I use / curly brace is my syntax here. Now I just embed the string property. And that's amazing. All these other languages make it so much easier to get your SQL injection. So Java had this idea that maybe we can do something here that makes this easier, but also less dangerous. And it's not just about SQL, right? Most of the strings we generate are either for another structured system, or maybe it's UI text or error messages. But a lot of what we do is JSON, XML, HTML, all kinds of things, right? That want another system to read. And that has syntax, that has rules for escaping. There might be the danger of injection there. So there are these format-specific rules. And what Java proposed in 21 and 22 was this. Now I use a text block. I don't have to, just because it makes it more readable on one slide. The point is here I have this / curly brace to reference the variable's property and the variable value. But I have this weird SQL thing in front of there. And I put that there so that the text block, which has these embedded variables, gets passed to something that understands these format-specific rules and does the right thing. For example, by preventing injection attacks. In this case, it could do escaping. It could also just go to the database, create a prepared statement with the question marks, fill in the variables, do the right thing. And all of that worked, and all of that was great. People didn't like the / curly brace syntax, and if you're one of those, I got bad news. That will probably stay in any future proposal. But this special source syntax for what is this SQL dot thing even? Like, what is it? It's a shortcut for calling a specific method on a specific interface. But it doesn't matter. It was just like it was decided very late in the game when it was very close to finalization 23 that like the syntax is just too much. It's like too much extra syntax sugar for something that maybe doesn't quite rise to the level of importance for that. Also, people have been since Java 8 begging for a way to not write f.apply5, to just write f of 5 or maybe f.5. And it feels kind of mean to now be like, no, you didn't get this, and you're not going to get it in the future either. But hey, for strings, we do something similar. So yeah, so the SQL dot syntax, this kind of thing, where you have a template formatter before the dot and then the template after the dot. A little bit too much. So it was pulled from 23. It's not even a preview anymore. So if you're one of the poor subs who tried this in 21 and 22 like I did, and you have a bunch of string templates lying around, I got bad news. You have to pull them all like teeth. It's not fun. The feature does need a redesign. I don't know when that will be done or ever, right? Like I cannot make any promises about the future. So it's a bit of a sad state right now, but I am, like personally, I am positive that we'll get something in this space. I'm not sure when. I really hope though that we do. If you want to dig deeper into the whole conversation, it's really, really interesting. Like if you're under the impression that these decisions get made lightly, I highly invite you to just click on that link once and just see the massive tree of conversation on just this discussion of, okay, the syntax isn't great, we should probably remove it, what do we do next? Just this portion, not touching on the implementation, or barely touching on performance implications. It's just like the surface level stuff. The discussion on the main list was crazy long. And if you don't want to read all of that, I gave a more detailed explanation in the What Happened to Java's String Templates video, where I reference a few of the details there. Okay. I got like 3 more minutes, but I'm going to save you from rushing through that. I know I've been talking a lot and fast, so I know you're probably somewhat happy to get out of here. Just to summarize Java 23 in a few slides, this is the new final features that you can use if you choose to upgrade. These are new preview features that you can choose to interact with. And there are a lot of existing preview features that we did not get to that you can also experiment this, which I can just recommend. Stream gatherers are a personal favorite of mine. They're so cool. So if you like stream APIs, go look at gatherers. They're really fancy. Earlier on in the slide deck is a section on those that explains them with also links at the bottom to more details. So yeah, Java 23 is not explosive like Java 23 doesn't make sense. I wanted to write not explosive like Java 21, which kind of coincidentally had a bunch, like it finalized a lot of pattern matching and virtual threads and other things that was crazy. But it's no slouch, and it continues Java's thoughtful evolution, specifically by continuing a lot of preview features, introducing a few new ones. And if you want to experiment with it, if you don't run in production, that's fine. Maybe you have a demo project or just a project locally where you try these new features out. You can get them at jdk.java.net/23, and it goes live. GA goes general availability on 17th of September, and we'll also have a live stream on that on the Java YouTube channel. So if you want to check that out, that would be nice. And maybe I'll see you there. And thank you very much for your attention.